Hi, I'm David Peacock, and today we are talking about exponential and logarithmic word problems, the greatest lesson ever. Quick note, if you are one of the people who are one of my students, you can follow along in your notes. That said, there are certain questions I have added that are not in your notes. Those will say bonus question. Thank you. Okay, for our first question, here's what we have. The hydrogen ions in a substance determine how acidic it is. The more hydrogen ions, the more acidic. The pH and number of hydrogen ions are related in the formula. The pH is equal to negative log of the hydrogen ions. So we'll see what happens there. Some of you who have taken chemistry might already know which of these two substances would be more acidic based off of your chemistry knowledge. But do you know the concentration of hydrogen ions in each? So we're going to start with milk. So the pH of milk is 6.6. And like I said, we'll deal with the pH of seawater being 8.5 in a minute. But what we want to do is find the concentration of hydrogen ions. So what I would do is I would put in my pH balance, or 6.6. I don't like that color. Actually, no, that one is super appropriate for acid. So 6.6 is equal to negative log of, and I'm going to say X instead of hydrogen plus just because I don't want to have to write it, because I'm not someone who wants to have to write more things. Just not a thing for me. Okay, so anyway, if you look right here, you see this whole negative log of X thing. Well, the problem is I don't want it to be negative. I need it to just be the log of X. And that negative changes it. So how do I get rid of a negative? Well, if I multiply or divide by -1, it's not going to change any values except for one little detail. See that 6.6? It becomes negative 6.6. And that's just going to equal the positive log of X. Think about it this way. If I say negative 5 is X, or 5 is negative X, those are going to be the same thing. So anyway, negative 6.6 is the log of X. Now, the problem is our X is still inside this log, and I need to get the X all by itself, and right now it just doesn't want to be all by itself anymore, but it has to be. So what we have to do is, and you'll remember this from prior lessons, what we do is we have to rewrite a logarithmic equation as an exponential equation to get that X out of the log. So what we do here is, if I don't see a base, what is the base? I'll give you 5 seconds. 2, 3. It's 10. Yay! See, it's like Blue's Clues, where everyone says it together, I'm assuming. Anyway, so the base is 10. So I would say 10, but now it's 2 whatever the answer was here. So 10 to the negative 6.6 is equal to X. And then I'll just put that into a calculator, because I don't know about you, but I do not know what 10 to the negative 6.6 is by the top of my head. I don't want to have to figure it out. So instead, I'm just going to say this. And so the answer ends up being, 2.5 times 10 to the negative 7. If you're looking, your calculator says e negative 7. What that means is it's scientific notation, meaning 10 to the negative 7th. Just understand that. So now let's talk about another one. Let's talk about seawater. Now, for the seawater, I'm not going to use green because that's going to be too close. I'm going to use red. So what we would do is, it's the exact same process. 8.5 is negative log of X. That means negative 8.5 is the log of X, which means 10 to the negative 8.5 is going to be X. And I already can tell that this is going to be a smaller number because it's 1 over 10 to the 8.5. But just to make sure, I'm going to plug it in, 10 to the negative 8.5. And sure enough, at first it looks like it's larger because it's 3.2. But then it's times 10 to the negative 9th, which means, remember, if you don't remember about scientific notation, because we haven't talked about it in this class, you've talked about it certainly in other classes, I'm sure, but the idea is it's how far you move the decimal. So if I say 10 to the negative 7, that means you would move the decimal that's right now, for instance, between 2 and 5 or 3 and 2, and you would move it, in the case of 2.5, 7 to the left from where it currently is. So like 1 would have been 0.25, 2 would be 0.025, and so on and so forth. Or in the case of 3.2, 9 to the left, meaning it gets even smaller. So because of that, which substance is more acidic? Milk. And now it's time for a bonus question 1. Bonus question 1. As a teacher, I'm always looking for fun ways to make money. I recently started a new business called Tutor. The concept is this. So many students are wanting my help because I'm such an amazing teacher. The problem is, I just don't have enough time for people to come in. That's why I came up with this great multi-level marketing company. Tutor is not an actual company. I do not charge for tutorials. Tutor! Here's how it works. See, that's me right there at level 0. Well, I feel I can tutor up to 3 students with my current schedule, and I charge $6 an hour. Student 1, 2, and 3. Well, each of those students can tutor up to 3 students. They charge $6 an hour, and I'll take 33%. Now you may be going, that's not fair, but remember, they're using the knowledge they got from me. So, that seems fair to me. And the great thing is, each of those students can tutor up to 3 students, and they can charge $6 an hour. The students who tutor them will also take 33%, and I'll take the 33%. So as you can see, level 1 is getting 33% from level 2. Level 2 is getting level 2 will get 33% if we have a level 4, and it theoretically can continue forever. So now what we want to do is we want to write an exponential equation to find out how many employees are on each level of this triangle-shaped organization. So what we would do here is we would say that y is equal to, let's see, the initial number of people in this company was just me. So 1 times, each time there are 3 times more to the x. And that would be our power. And so x is going to be the number of people on that level. So for instance, if we're talking about, let's say, level 2, that would be 1 times 3 squared, or 9, which, fun fact, there are 9. On level 3, it's 1 times 3 cubed, and sure enough, there are 27. And if you look at level 4, there are 81. So there you go. So how many employees would Tutor have on level 10? So what we do is we say 1 times 3 to the 10th. And let's find out on level 10 how many people are working for this wonderful and definitely not pyramid-based organization. 59,049 are there on level 10. And just imagine how many there would be on level 11 or 12. It's a great process, and soon everyone could be a tutor. The U.S. population of peninsular bighorn sheep was 1,170 in 1971. By 1999, only 335 remained. Write an exponential equation to model this decline in the population. So, if we're going to write an exponential equation in this case, what we have to do is we have to figure out our percent decrease. And we don't know that yet. But what we do know is our initial value was 1,100. So, you know what? I'm going to write this a little smaller because it's going to take a while. 1,170 times x, because I don't know what our percent increase or decrease is, to the how many years? So from 1971 to 1999, it's 28 years. And in those 28 years, only 335 remained. Now, we're about to do something that we're going to be seeing a lot. Our first step here is, I have an exponent, but I want that by itself. So what I'm going to do is I'm going to divide both sides by the number with it. So in this case, I'm dividing both sides by 1,170. So my first step is to find out what 335 divided by 1,170 is. And in this case, that means 0.28. Well, you know what? 28.29 is about x to the 28th. Now, the thing is, that means that there's only 29% of the original population. But how do we figure out how much it was declining each year? Well, the way we do that is by getting rid of that 28th power to just get x. Now, that means that we would find the 28th root, but I don't want to try to write 28th root, especially not in a calculator. So remember, another way of writing 28th root is to multiply both sides by 1 over 28. That means the 28th root. So I'm going to take the number I just got and do 1 over 28. And I'm going to end up getting that x is about 0.96. So our final equation would be 1,170 times 0.96 to the 28th. Oh, sorry, we wouldn't say to the 28th as the equation. We'd just say to the x, because this works for all numbers, and that's our final equation. So now let's move on to part 2. In what year might only 5 bighorn sheep remain in the United States? So to find that out, what we have to do is we have to use the formula that we already have solved here. So what we would do is, in this case, the 5 is not x, because we're not saying in 5 years. We're saying, when will it become 5? So it's 5 equals 1,170 times 0.96 to the x. So our first step is exactly the same. We divide both sides by 1,170. Now, 5 divided by 1,170 is going to be a much smaller number than our last one. In fact, it means that I'm going to have to go more than 2 spaces. I'm going to say 0.96 is approximately 0.96 to the x is approximately 0.0043. So I'm going 4 digits. Now, remember, now that we have an x in the exponential section, we have to do the opposite of what we did earlier. Instead of going from log to exponent, we're going from exponent to log. So what we would say is log base 0.96 to the 0.0043 is approximately x. Now, our next step here is going to end up being just solving. Now, as you might remember from the last lesson, we can use change of base formula, which is log of 0.0043 over log of 0.96. If you have a TI-84, you can also just plug this into your calculator as that if you don't want to, although I actually recommend change of base formula. I find it easier. And what you end up getting is that x is approximately 133.49. So about a year, 133 and a half years, which means 5 bighorn sheep will remain in the year, well, let's see, we have to do 1971 plus 133, which means in the year 2104, in about June of that year, there will only be 5 bighorn sheep left. Thank you for listening, and please donate. And now it's time for bonus question 2. Quick warning, this one's a little spooky. In the year 1492, the first vampire, or as they are more commonly known, Dracula, was brought forth. His name was Count von Count. For his first 200 years of existence, he resisted the urge to feed on the blood of his fellow Muppets. However, as time went on, he could not evade the hunger. In a frenzy, he turned 50 Muppets into Draculas. After this initial feeding, the number of Draculas has gone up 2% each year. So our first question is, how many Draculas were there in the world when Sesame Street premiered in 1969? So to start this question, what we have to figure out is what our initial value is. Now, my first thought is 1, for there was but one vampire, and his name was Count von Count. And you could count him very easily. Von, However, our increase only begins after the initial feeding. And Count von Count, in that monstrous act, turned 50 Muppets into Draculas. Meaning, if you include himself, there were a total of 51 Draculas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Draculas. 11, 12, and so on and so forth to 51. Now let's talk about the year. Let's talk about our increase first. It's increased by 2%, so 1.02. Now, let's talk about our x value. Once again, we might naturally want to think the year 1492, for that is when he was brought forth through the dark magics. However, once again, we are looking at when he turned the 50 Muppets. And that was 200 years later in 1692. So to figure out how many years it was until 1969, we would do 1969 minus 1692. So let's see, 277 years. So we would raise that to 277th power. And when we do that, and we put it into our forms of calculation, we discover that the amount of vampires or Draculas that were there when the world premiered, when Sesame Street premiered to the world in 1969, normalizing this monster, there were now 12,297. It says 0.5, although that seems a little odd. I guess there was a halfula, if you will, as well. Now there is a second question. In what year will there be 1,000 Draculas? Oh no, Bert and Ernie, you've been turned, and it's the sun! No, not Bert, Ernie, and the Count! So let's plug in our values. 100,000 equals 51 to the 1.02 to the x power. So our first step is to divide a 100,000 by 51. At which point we get 1960.78 is approximately 1.02 to the x. At which point we must get our x by itself. And so we switch this into a log. It is log base 1.02 to the 1960.78 is equal to, or is approximately, x. And let's plug that into our calculator. Answer divided by log of 1.02. And you end up receiving our answer of x is approximately 382.83. So that would be the number of years So in what year would it be? We take our initial year of 1699 and we add 382 and we discover that our answer 1692 plus 382 ends up being 470. In the year 2074, there will be 100,000 Draculas, even with the sun. So let's talk about example 4. This is about a very normal child with no privilege whatsoever, just normal amounts wants money. So a parent raises a child's allowance by 20% each year. The child's allowance is now $8. So we are going to want to write an exponential equation to represent the child's allowance in 20% each year. So what we know is that the initial value is $8. And that it's increasing by 20. So we do 1 plus 20%, or 1.2, to the number of years. Hey, look, he seems very happy. Money, money, money! All right. And that would be equal to y. Now, in this case, we want to know what it'll be when it's $20. So 20 is our y value in this case, not our x. Equals 8 times 1.2 to the x. Now, our format here should be pretty normal to you at this point. First step we do is divide by 8. 20 divided by 8 is going to end up being 2.5. $2.5 is going to equal 1.2 to the x, meaning we can rewrite this as log of 1.2 is 2.5. Or as I would put it in my calculator, I would end up saying log of 2.5 over log of 1.2. And we end up getting that he will get his increase in money in about 5.03. So about 5 years. He will be at $20. All right, now it's time to play Would You Rather? Would you rather have a penny a day doubled for 30 days or $10 million up front, and why? I'll give you a second. Okay, so which one did you choose? If you chose $10 million, sit tight. But now we're going to find out if you had chosen that penny a day, because we don't know what that is, how much money you would have. So remember, a penny is $1. I would be going, it's doubling each day to the 30 days. So a penny a day, let's see, a day, after 1 day it's 2 cents, after 2 days it's 4 cents. So 0.01 times 2 to the 30th power ends up being, and this is true, 10737,418.24. Let's see. Whoa, that ends up being $10 million, $737,418.24. That's right. If you had chosen to have that penny a day doubled, you would have over $10 million in just 30 days. All right, so let's look at example 5. So for example 5, we have an investment of $100, which is now valued at $149.18. The interest rate is 8% compounded continuously. How long has this money been invested? So we have $149, but that's not our initial value. Our initial value is, you know what? $100. Now it's at 8% compounded continuously, so we use our continuously compounded formula of e to the rate, which we know is 0.08, and how long it's been in, which is not mentioned. So I'm going to put x. That's all going to be equal to the amount that we now have. The amount we now have is $149.18. So there we go. So let's talk about our problem-solving process. The first step is what we've been doing almost every time, dividing by 100. This ends up meaning that what we have is 1.4918, and that's going to equal e to the 0.08x. Now our next step is we want to get that 0.08x out from being an exponent. And we do that by turning it like we've been doing to a log. But because we have log base e, we rewrite that as log n, or natural log. So we will write ln 1.4918 is equal to, is equal to 0.08x. Now let's do our math real quick. So let's see. We go into our calculator, we put ln 1.4918, close parentheses, and that ends up being basically 0.4 when we round. And that's going to be 0.8x. Then we divide by 0.808 from both sides. Not 0.08x, just 0.08. And we end up getting 5 is about x. It's a rounded number. It's not actually exactly that. So it was about 5 years. All right, let's try this one. So it says an investor sold. All right, let's try this one. So it says an investor sold 100 shares of stock valued at $34.50 per share. The stock was purchased at $7.25 per share 2 years ago. So what we're going to be using, find the rate of continuously compounded interest in the investment. Please note, stocks don't actually get continuously compounded interest. This is just, we're seeing what the rate would have been if it was a savings account instead. So in this case, 7.25 is our p-value times e to the, we do not know our rate, but we do know it was 2 years, equals 34.5. Now you may go, why aren't you worrying about the 100? Because the rate for one share is going to be the same for 100 shares. So our first step is, once again, we divide. In this case, we divide by 7.25. So 34.5 divided by 7.25 is, we end up getting 4.76 is about e to the 2x, at which point natural log of 4.76 equals 2x, or is about 2x. So that ends up being 1.56 is about 2x, so we divide by 2. 0.78 is about x, or 78%, which is an amazing return on investment and very rare. And there we go. That's definitely it.
Wait, what's that? Is it a bonus question? Thanks to the huge success of the Mountain Dew General Store, as well as the introduction of Mountain Dew Ice, which is nothing like Sierra Mist, shares in PepsiCo have been growing exponentially. One share in 1978 was worth a mere $57. In 2018, a share is now valued at $121.76. Write an equation for the continuously compounded interest of someone who bought 100 shares in 1978.
So let's talk about our initial amount. Remember, a single share is going to end up being the same as if we're talking about all of them. So here's what we do. 1.57. That was our initial value. In this case, it's 1.57 times e to the x, and then 40 is equal to 121.76. So our first step is 121.76 divided by 1.57. So what we end up getting is 77.55 is approximately e to the 40x. At which point we would say the natural log of 77.55 is approximately 40x. So natural log, and I end up getting 4.35 is approximately 40x. Our next step is we divide by 40. And that means x is approximately 0.11 or 11%. And there we go. That's it. Thank you very much. I hope you had fun. If you would, please like, subscribe, all that jazz. And here you go. Bye.
Mountain Dew!